Okay guys, so I want to go ahead and get some of the notes for 9.4 out of the way. I think this will be a pretty easy video. This should all be a review from last year. We're going to be using some formulas that we use when we talk about money, all right, and how the interest is compounded. So when we talk about interest being compounded, as you can see, that's what this is about. It refers to how often a portion of the interest is added into your account. So we're just going to add it up here. How often is interest added to account? Whether you're talking about a loan or investment, this really holds true. So the first formula, you're going to recognize this from last year. It's kind of long and scary, but it's not that bad once you know how to use it. A equals P times 1 plus R over N to the NT. Okay. And let's go ahead and talk about what the different parts mean. A is your ending amount. P is what's called your principal, which is actually a pretty fancy name for starting amount, really. That's all that means. R is your interest rate, and you're going to want to make sure that when they give you that interest rate as a percent change to decimal when you plug it into the formula. T is years. Alright, so how many years it's invested or how many years you have the loan. And N is number of times interest compounded per year. That's usually the hardest thing to figure out, okay? Now, there's going to be another formula. You can see further down the page, there'll be another formula. So it's going to be important for us to know when we use either or. We use this formula when interest is compounded. Let's see, daily, weekly, monthly, quarterly, and I'm going to add a row down here, quarterly, semi-annually, and annually. I don't think I missed any. Daily, weekly, monthly. Yeah. So when we say that the interest is compounded daily, that means that N will be 365. Weekly means N is 52. Monthly means that N is 12. Quarterly means N is 4. Semi-annually, that's twice a year, that means N is 2. Annually, N is 1. Alright, so that's just referring to how often is a portion, not all of the interest, but a portion of the interest added into your account. Now, in some cases, your interest is actually compounded continuously, which is sometimes hard to imagine, but a portion of your interest is added in all the time. Okay? So that requires us to use this formula, and you probably recognize it from last year as well. Some people call it the shampoo formula because it looks like the shampoo pert. And we only use this when interest is compounded continuously. A lot of the letters are repeated, so A is still your ending amount. P is your principal, again, starting amount. R is your interest rate as a decimal. T is years, and E is actually not a variable. It's actually, it's called Euler's constant. Euler is actually spelled like that. It was a mathematician, pretty famous guy. I think he found this constant that kind of comes up a lot. I think they use it in chemistry too. Anyway, it's kind of like pi's less famous cousin. it's about the number 2.71828. It keeps going on forever, okay? You don't even have to know that part because there is a nice little button for it on the calculator. If you look and hit second divide by, gotta turn that on, second divide by, you can see that number pops up for us. So you don't have to have that memorized. The calculator has E for you. But the thing with this formula, you really want to make sure you're only using it when the problem says that the interest is compounded continuously. All right? So if it's compounded any other way, you actually use the formula at the top. So if we look at this example here, it says, suppose that Cooper is planning on going to Pitt, best college in the world. However, and this is a fairly accurate figure. I believe I got this from Pitt's website last year. So it actually will probably be a little bit more, hopefully not a lot more, but a little bit more today. But let's say you need about $27,000 to pay for tuition, room, and your meal plan. Now, this thing called a Stafford loan, it's actually, it's a pretty typical type of loan that is used for college loans. Its going interest rate is 3.4%, and it's normally compounded daily. So that's key there, compounded daily. What that says is we're probably going to use that first formula. We want to know how much will he owe, so ending amount, how much is his ending amount in 4 years if he doesn't start making payments until he graduates. And that's pretty typical. Most students can't make a payment while they're in college. So usually you don't need to start paying back your student loans until you graduate. But all the time you're in college, it's accumulating interest. So we want to know how much you'll owe. So we'll set up the formula here. I recommend writing it out until you really have it memorized. Then plugging in the numbers. So 27,000, that's our starting amount. Interest rate, 0.034. You got to change that to a decimal. Compounded daily is 365 times in a year. So we use that again up here in the exponent, and then t is 4. So this is kind of complicated. When you go to plug it into the calculator, you're going to want to make sure you do that correctly. So 27,000 parentheses 1 plus 0.034 divided by 365. Close the parentheses, caret for the exponent. If you have a newer calculator, you won't need the next set of parentheses, but if you have an older calculator like I do, we need another set of parentheses because 365 times 4 needs to go in the exponent. Enter. That's the amount that Cooper is going to owe the day he graduates. Since it's money, we're going to round to 2 decimal places. Okay. So that means he's going to take out this loan for $27,000, but he's actually going to owe that much when he graduates. The bank is going to charge you interest. Okay. Now, here's the really scary thing. The day that Cooper graduates, it is unlikely that he is going to pay that back in one lump sum. He's not going to be able to afford that. He's going to be making payments, but even as he's making payments, more interest is accruing. It may take him 5 or 10 years to pay that off. And so he actually ends up paying much, 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 much more, which is terrifying. The other thing to think about is if you needed a loan your freshman year, you're probably going to need one sophomore, junior, and senior year. So you're just going to be adding to this with more loans on top of that. So the number does very quickly increase. Okay. That's why we want to get those college scholarships. All right, so that's how we set up a problem that looks like that. Let's tweak that a little bit. Let's look at the next example. And let's say that everything remains the same for Cooper, except his interest is compounded continuously. So that means we're going to use PERT. So P is still 27,000. I don't really need those parentheses. Let me take that away. I don't need the parenthesis here. Okay. I need a 0. And then E, remember, is just some number. R is 0.034. T is still 4. So when you go to plug this in to the calculator, 27,000. When you want to use E with an exponent, you actually hit second ln, it's right beside the 4 button. And it already does the E with a little caret for you. And we can go ahead and put the exponent in, enter. And what's surprising is you may have thought before you started the problem that, oh my gosh, compounded continuously, interest is going to be constantly added in. Oh my gosh, that's going to have a huge effect. It doesn't. It's only a small portion of the interest that's being continuously added in. So, no, we're not talking about a huge difference here. What does make a huge difference is the interest rate. If I were to change this interest rate to something smaller or bigger, you would see a bigger change in what's happening here. Okay, so when you guys go to find your own loans, whether it's for a car or for a college loan or for a house, your biggest concern is the interest rate. How it's compounded really won't have that much of an effect. So something to keep in mind. What I want you to do for homework for the rest is look at the next 3 examples. I want these examples to be completed by the time you come into class tomorrow. So we'll see how well you're understanding everything. Okay? All right, happy computing.